Hello and welcome. What you see here is the control unit of a 60-bit relay computer. And first I show you a little video how it runs at the moment with full speed. Okay, that was not bad for a relay computer system. And now with a slower clock speed. And what are the different parts of the system? This marked part here is not really part of the system. That's an Arduino, and this Arduino is used for the clock, and he is used to support the system with the opcode, an opcode for a no operation command and the opcode of the load accumulator with a constant command. This part here is the instruction register. It stores the 16-bit command, the opcode, and some additional information. And the 16 lights on front of this instruction register module shows us the actual values stored in this register. The instruction decoder is used to generate the signal for each of the 12 possible different instructions of the system. The state machine register is used to store the actual step of each command. Each command consists of different steps. The knob command 2 steps and the loader accumulator with a constant command 4 steps. And in this part of the system, the actual step is stored. We can see the actual step on the 4 lights which are mounted on this part of the system. The state decoder simply generates a signal for each of the different steps of the system. The command control units are generating the signals for the complete control unit here for the different commands, for example for the knob command or the load accumulator with a constant command. These commands behave very differently, and the exact behavior of the system for each of these commands is controlled by this little unit here. The command line matrix is a little bit a translator. The command line units are controlling the control unit, but they are using something like a micro command. And each micro command consists of different control lines for the rest of the system. And this command line matrix is the translator between micro commands and the control lines of the rest of the system. The last module I want to show you is the control line timing module. In a relay system, we have to clear a register before we can set it. And this module here is generating a clear signal to a register if we want to set this register. And the timing of the clear signal and of the set signal is based on the 4 different clocks we are generating by the Arduino. And this module has a second very important task. This module is responsible for the instruction register. And it is responsible for the clear, the set, and the output enable of the instruction register. The system has to be very careful about the timing of these 3 signals. If we switch from one instruction to the next instruction, for example, from the knob instruction to the load the accumulator with a constant instruction, the control unit has to be extremely careful with the timing of these 3 signals, because otherwise the state machine will be completely confused. And when you are looking at the pictures of the system, and if you are listening to my explanations, maybe you are missing something, because I'm talking about an accumulator and so on, but there is no accumulator. That's because I started the build of the system with the control unit and the rest of the complete system, the registers and the complete address calculation, the ALU, will follow during the next year.